Okay, we're gonna get started. This is the second installment of helping Rose. We'll start off with this, and I'll do as many problems and as many pages as I can in this one sitting. If I don't get through all of them, I'll make another video. And I'll probably not do all the problems on each one. With learned skills, he should be able to go back and do them. But if you have specific questions on specific problems, I will just um go back and help with those. So the table below shows the number of animals at a local petting zoo. Write the ratios of ponies to rabbits. So in the last video, we learned what a ratio was and how it's seen. So if you think, it's just comparing it, right? So ponies, rabbits. There are 2 ponies and 3 rabbits. So ponies, 2 rabbits, 2, 2, 3. That one should be simple. Okay. And then ratio of ponies to sheep, same deal, right? And then rabbits to goats, should be able to do those ones. How many animals are at the local petting zoo? Just like with the hats, how are you going to get the total? You add them up, and you should know how to add them up, right? And that'll give you whatever that is. And then write the ratio of rabbits to all the animals, right? So rabbits, and then the total amount, comparing those, right? So 3, 2, whatever that is. That should all just be review. And the ratio of boys to girls to school in school is 2 to 3. So you should be able to figure this one out. This ratio means for every blank amount of boys, how many boys to, remember the colon is 2, girls. Right? So you should be able to figure that out. And this ratio means that every 2 boys, there are blank students. Now, students is like how many animals there are, how many in total. So remember, add those up, and that'll equal the amount of students. Just the ratio of students. And then write the ratio. So it'd be that number and that number with a colon. Pretty simple stuff. Now we'll move on to the next one. Okay. Let's see here if we can read all the questions. If we can't, we're going to have to figure it out. Okay. may end up skipping those ones. You can just skip past this part until I get to actually doing the problem. So we'll start with how many small cubes are needed to fill the large cube. So we have, this is 1.5 feet, and one of these is 4.5 feet, right? So in this could be one there, right? So divide 4.5 by 0.5. Which equals 9. So 9 of those could go in this section here. So if we're looking at a big box, let's make our box bigger so we can properly see. 9 of those small boxes are going to go there. So that means another 9 are going to go here. And then also another 9 are going to go there. And that would be the volume. So that's that 9, that's that 9, and that's that 9. So if we multiply those, 9 times 9 times 9, this should be it. I'm kind of working while distracted, so Rose, you should double check me. So 7 to 9 of the cubes can fit in there based on my math, hopefully. Okay. Let's do this one here. Which question is a statistical question? How much does Colin weigh? What are the heights of the people in the Kelly family? How much weight did Colin gain in 1 year? What is the difference between the height of Colin and the height of Caden? So you have to think of what statistics are. And typically it's comparing data. So if you had a graph, for instance, or a bar graph, or a pie chart, all of those would be statistical. Like if you're saying 24% of people prefer to eat Cheetos to Lay's chips, that would be statistical. So if you're looking at how much Colin weighs, that can't be statistical because that's just giving one thing that only has one answer to Colin's weight, and that would fill up the whole pie chart. Essentially, what is Colin's weight? How much did Colin gain in 1 year? That would be taking his initial weight and his final weight and subtracting. or the other way around if you're gaining. What is the difference between the height of Colin and the height of Caden? You would subtract Colin's height and Caden's height. So none of those are statistical. Except for B, where if his dad was 6 feet tall and his mom was 5'7", and he was 5 feet and his brother was 5 feet, and then his sister was 4 feet, let's say, then you could put that on a graph. So there's one person who's 6 feet, one person who's 5'7", 2 people who are 5, and 1 who's 4. So B is the answer. Let's see, what else can we do? Let's move on to the next one. What is the area of the figure below? Now, I definitely know how to do this. Think of triangles as rectangles, but in half. So as you can see, if you just flip that, it gives you a rectangle. And so what's the equation for, what is the equation for a triangle for the area of a rectangle? It is height times length. So that would be height and that would be length. Or you could say height times width. That could also be width. It doesn't really matter. So a triangle would just be half of that. So times 1/2, or divided by 2. So let's think on it here. What is 1.5 times 2.5? You can do that calculation for now. Got it? Okay. But also think this is doing fractions, right? So we need to convert these into uneven fractions. So 2 times 1 is 2, plus 1 is 3/2, times 2, 4, 5 equals, you can figure that out. Got it? 4/15. Because you just multiply straight across. And this can not be simplified, because that can break down into 5 and 3, and that's about it. and that can break down into 2. And 1 if you're dividing by 4, but you can't divide that by 4, or 2. So that's all you get. So what you need to do is find out how many times 4 goes into 15. So essentially you divide 4 by 15, but it's not going to go in wholly. So 4 goes into 16, but we don't have 16. What's 1 down? 4, 8, 12. Oh, we're going to have to stop there because then it goes to 16. So 12. 4 goes into 15 3 times. And that gives a remainder of what's 15 minus 12? 3. So our answer is E. Oh, but no. We have not divided that by 2. Because that's would be the area for the rectangle, but not for the triangle. So you can't forget that. So we're going to go back to our improper fraction and divide that by 2. Or multiply it by 1/2. Which would be a lot easier. So 15 over 8. Which also cannot be simplified. Just like this could not be simplified, that can't be simplified either. So we have to look how many times does 8 go into 5 or 15? Only once. So 1, and what's left over? What's 15 minus 8? Figure that out real quick. 7. So 7 over 8. So that makes the answer B. This time, full and truly. Okay, I can't really see that one, so we'll move on. Let's see, G. What is the area of the parallelogram? And then part B, what is the fraction of the parallelogram? What fraction of the parallelogram is this triangle? So, you gotta look at it this way. This right here is the same area as, let's change my color. It's the same area as all of that. It would be just like if you were taking this little green section here and moving it over here. And just like we covered with that triangle, just the last problem. So we already covered that, so we should know how to find the area of the rectangle and the triangle. All of this is 12 feet. So what do we have to do? length times width, height times width. Just understand that we are multiplying that by that. Well, actually all of that by that, right? So 4 times 12. Figure that out real quick. I'll do it too, so I know how long it would take you. 48. So 48 feet squared is the area of the whole thing. What fraction of the parallelogram is the triangle? Well, we already discussed that a triangle is half of a rectangle, which this is just a rectangle but slanted. So that means it would be 1/2. Then we can do this one over here. Ellis has the following set of numbers: 20, 9, 14, n, 18, and 18. If the median is 18, which two of the following could not be n? So let's look and line them up, excluding n. 20 is definitely our highest. 9 is definitely our lowest. And remember, a median is the number directly in the middle of all the numbers. So it should have the equal amount of numbers on each side of it. And if 18 is our median and 14 is lower than 18, n should go right here. So let's look at the numbers we have listed. 143 would not work. Wait, give me a second. It could work because it's on this side, and 20 could be either higher or lower than n, as long as n is on this side, because there's already 2 over here. 10 could not work because it would be lower than 18. 17 for the same reason. 19 could work. And 22 could work. And it does ask which 2 of the following could not be n. So we found it. 10 and 17 both could not be n. But 19 is higher than 18. 22 is higher than 18. And 143. They are all higher than 18. So they could be n. Okay, let's see. Enter your answers in the boxes. Simple division problems. I will do the first one, and we will do long division, because I doubt they really want you to be doing this with a calculator. So 537 divided by 2.4. Now, when you're dividing with decimals, remember that there's a decimal here that you cannot see. So you have to move it over because you're moving that over. So 24 divided by 53. How many times does 24 go into 53? It goes in twice with a remainder of, let's see, 24 plus 24 is 48. minus 53 so that should be what, 5? 5. And we can subtract that. Oh, wait. 48 minus 53, and that should be 5. Because 2 times 24 is 48. And that gives you a remainder of 5. Drop down your 7. 57 goes into 24 the same amount of times, 2 times. So that's 48 again. 57 minus 48 is 9. Drop down 0. How many times does 90 go into 24? 3 times. So now we're in decimal territory, and we can just carry it out until, or are you still at the grade where you do remainders? I'm not completely sure. But either way, 24 times 3 is 72. And that means 18 is your remainder. Now 18 does not go into 24. So we have to, and there's nothing left to drop down. So we add another 0 and drop it down again. So 180 divided by 24 is 7.5. So that means it goes into it 7 times. And we will see what the remainder is. 24 times 7 is 168. So 180 minus 168 is 12. So this is just a continuation up here. Pretend that went up there. How many times does 124 go into 12? No times. So we add another 0. And we can drop it down. Now, how many times does 120 go into 24? 5 times exactly. Down to 0. So our answer is 223.75 for that problem. That seems like a lot of work for one problem, but you just kind of got to power through. I'll do this page, and then that's all I'm doing for this video. If you have specific pages you want me to do, tell me, Rose, since I have them all saved. But I don't know when I'll get to all of them exactly. So the number of minutes Oliver spends working on math is 60% of the time he spends working on homework. So this can, just by this, let me get my pen back. Just by this amount of information. We can give a few visuals. So if we were to have a pie chart, 60%, we're going to say that's about, so 60% of the time, all of it's homework, and that 60% of the time is math. There's just a small visual. And then you can also write it as a ratio. 60, 100. Remember when we were learning about ratios? 60 to 100, which is also 60 over 100, which we can simplify to 6 over 10, and then simplify that even farther into 3 over 5. So 3/5 of the time he is working on math. On Monday, he spent 30 minutes working on math. How many minutes did he spend in homework overall? So I can show you really quick how to calculate that. 3/5 equals 30 over x. And x is how much homework he did in all. I think you could also do this in a couple other ways, but this is the way I'm going to show you. So we're basically going to set up an equation. So these two, we're going to multiply them. 5 times 30 is 150. And those two, we call this the butterfly. See, it kind of looks like a butterfly. Equals 3 times x. So then we set this up into an equation. 150 equals 3 times x. So then we just need to do inverse operations. 3 divided by 3, those cancel out. 150 divided by 3 equals 50. So that would equal x. So 50 minutes is what he spent on homework overall. If he spent 30 minutes working on math. Now we'll go to our last problem. Select two expressions that are equivalent to 4 times 3 plus d. So you have to distribute your 4. So that would be 12 plus 4d. Already you can see this one equals, right? That's a given. And based on the fact that we distributed that, which means this is 4 times 3 plus 4 times d, right? Because 4 times d is 4d, and 4 times 3 is 12, and we're adding them together. You can see here, d equals just that. So it's a and d. That one was pretty simple. Anyways, that's as much as I'm doing for right now. Rose, tell me specific problems that you want me to do.